Okay, we continue applications of quadratic and related theory, solving equations and inequalities, lecture 1. In section F, square roots. As you can see, we have a square root on the left, and that is equal to an algebraic expression on the right. The way we deal with this is that we bracket the entire left side with the square root and square that to get rid of the square root. We do the same on the right. So the square root and the square are set to cancel, but you'd understand that from your knowledge of exponents. So that would simply give us x minus 2 equals 4 minus x all squared, which will expand to give us 16 minus 8x plus x squared. Now, an important point to note is we squared the left and we squared the right. This introduces a root, as it were. In other words, we'd get an extra answer for x. So you'd need to actually test your answers at the end of the problem. So let's continue. We have, therefore, x minus 2 equals 16 minus 8x plus x squared. Bring all terms to one side, and that should give us x squared minus 9x, where the x from the left moves to the right, and 16 added to 2, 2 moving from the left to the right, giving us 18, and the left becomes 0, which is effectively like the right equals the left equals the right. So x squared minus 9x plus 18 equals 0, checking my work as well. Now for the factorizing part. It would seem that the factors of 18 are negative 6 and negative 3 in this instance. So we've done examples of this type earlier in lecture 1. So I'm doing that, checking x squared plus 18 minus 9x. So the first bracket equals 0, or the second bracket equals 0. So x would be equal to 6, or x would be equal to 3. Now, this is one of the sections in mathematics where you'd need to test your answers, because as I say, by squaring the left and the right, we introduce a root, we introduce an additional answer for x. So the left side was simply 6 square root of 6 minus 2, which was square root of 4, giving you 2. And the right side was 4 minus x, which is 4 minus 6, giving us negative 2. Left is not equal to right. Therefore, we'd conclude that x is not equal to 6. Let's test the x equals 3 answer. The left side would be square root of 1, which is 1. And the right-hand side would be 4 minus 3, which is 1. They are equal. So indeed, x equals 3 is a valid answer. And that simply completes that problem with the test at the end. Guys, now let's go on to inequalities. We've got a pretty interesting one here. I just want to see if this factorizes using the discriminant method. 25 and 24, 49. Yes, indeed, it does. And it would seem it's going to be x plus 6 into x minus 1 greater than 0. Let's check our work. X times x is x squared. 6 times negative 1 is negative 6. And 6x minus 1x is 5x. Now, critical values are indicated by the abbreviation CVs. So you may use that abbreviation. CVs are obtained in the same manner that we'd solve an equation like the one that I've just asterisked on the left. So x plus 6 equals 0, x equals negative 6 would be a critical value, and another critical value would be x equals positive 1. That's simply making the first factor equals 0, second factor equals 0 to get our critical values. Critical values do not mean these are the solutions to the inequality. It simply means that they are critical. They are important to us. They are significant, right? So here's a -6, here's a 1, relative positions on a number line. The greater than 0 will indicate that we can't include critical values. So diagrammatically or graphically, if you like, we indicate that with an open circle. Now, some practitioners like to use a parabola to explain this particular diagram. I'm going to use both, let's say, both methods. One that I call my imaginary board game, starting on the right, moving to the left. I sense a number, so I go down to the number, and I continue left until I sense another number. I go up to that number, and then I continue left, searching for more numbers. There are none. So simply that would be my diagram. The greater than 0 in the original question indicates to me the answers must be above the number line. Greater than is above, less than would be below, equals would be on the number line, right? So let's go back to where we were, which was greater than. And the greater than answers are simply x going from a very large negative number to -6, and x going from 1 to a very large positive number, which is positive infinity. So the solutions are x belongs to -infinity, semicolon -6, or x belongs to 1 to infinity. Now notice the brackets. The brackets are round for -infinity and +infinity. The brackets are round for -6 and 1, because this was what we call a strict inequality greater than 0. Let's come now to algebraic fractions. Here we look at the denominator, and the denominators are x plus 1 and x minus 2. That implies a lowest common denominator, which is a product of these denominators, which is x plus 1 into x minus 2. Whenever you get a lowest common denominator, declare your restrictions in any work that you're doing, exams or other. So the restrictions derive from the LCD. So we write down the word restrictions, and let's work on the restrictions. An LCD is a denominator algebraic expression. A denominator may never be 0. So that tells us that x plus 1 equals 0 will give us a restriction. So x equals -1 is a restriction. Another restriction is when x minus 2 is 0. So x equals +2 is a restriction. Why is this significant? When we do produce our final answers, we'll compare them to these restrictions. All right, so now we have our LCD, which I'll write once. And I'm going to make the right-hand side equal to 0. So I'm bringing the expression from the right to the left. I'm just producing my numerator now. So x plus 1 will be multiplied with x minus 2 to get to the LCD. For that reason, it's x plus 2 into x minus 2. X minus 2 will be multiplied with x plus 1. For that reason, -3 is multiplied with x plus 1. All right, so apparently I need a bit more space here because I brought terms to the left side. So let's do that and expand the long division sign, something like that. And then we've got -1. The x plus 1 will be multiplied with x minus 2 in the denominator. So it's multiplied with x minus 2 in the numerator. Brought to the left, so that's a -1. So that's equal to 0. Okay, let's check the work. X plus 2 is multiplied with x minus 2 minus 3 is multiplied with x plus 1 minus 1 is multiplied with x minus 2. Now, note we did declare the restrictions and we have an expression on the left equals 0. So we simply can drop the denominator at this point only because we declared the restrictions. So we're left with x squared minus 4 minus 3x minus 3 minus 1x plus 2 equals 0. Okay, x squared minus 4 minus 3x minus 3 minus x plus 2 equals 0. I'm actually checking my work when I repeat myself, indicating to you that's a very important thing to do as you are producing your work. So that gives us x squared minus 4x minus 7 plus 2 is negative 5, and that would be equal to 0. Okay, so I'm checking x squared minus 4x looking good, minus 1 minus 5 looking good. All right, so this is going to give me x minus 5 in one bracket and x plus 1 in another equals 0. Let's check. X times x is x squared, minus 5 times plus 1 is negative 5, and minus 5x and plus 1x is minus 4x. So guys, x minus 5 would be equal to 0. That would imply x equals 5, or x plus 1 would be equal to 0. That would imply x equals minus 1. Aha, now we need to compare these answers to our restrictions. Let's check again now. X is plus 5, x is negative 1. I hope you all can see x equals negative 1 is a restriction. So here, under x equals negative 1, you can write the words not valid, or you can write x is not equal to negative 1. That would be a perfectly acceptable representation of your answer. Okay, guys, we go on to the last part of applications of quadratic and related theory, solving equations and inequalities. We will do a simultaneous equation, a set of simultaneous equations. So the examiner has given us a linear equation that I've numbered equation 1, and a quadratic equation, which I will number equation 2. All right. Now, one of the simplest ways is to substitute from one equation to the other. So let's firstly look at equation 1. We'll say to the examiner, from equation 1, so we're signposting, right? We can see that y is equal to 3x minus 2. That's bringing 2 to the left. And this gives us equation 3, if you like. So we'll tell the examiner, we're going to substitute equation 3 into, we completed working with equation 1. So equation 3 will be substituted into equation 2, right? With my signposting, I just want to underline them. And let's proceed. So equation 2 says 3 times y, but y is 3x minus 2, as we found in equation 3, plus 9x squared is equal to 4. All right, so with all our prior and current knowledge, this equation will now be resolved as 9x squared plus 9x minus 6. I'll bring the 4 to the left, equals 0. Okay, so 9x squared plus 9x minus 6 minus 4 equals 0. So this simply gives me 9x squared plus 9x minus 10 is equal to 0. Okay, I'm going to quickly do my discriminant, which is delta is b squared minus 4ac, to check if this latter equation factorizes. So b is 9, so 9 squared is 81, minus 4 times 9 is negative 36, times negative 10 is plus 360. Wow. And this gives us 441. So at this point, if you'd bear with me, I just need to use a calculator to check the validity of my discriminant. It looks unusual. So that's 81 minus 4 times 9 times negative 10. 81 minus 30, 81. I'm just going to redo that. Minus 4 times A times C. And that will give me 81 plus 360. All right, so I've got some light on the problem. Let's look here now. 81 plus 360, and that's 441. Just want to see if the answer, so that's 21 squared, which is desirable. 21 squared. So when our discriminant is a square number, we will indeed get real and rational roots for the equation I was examining a short while ago. So just for completeness, I'm just putting equals 441 here. At this point, I was just checking the work that I had rushed through at that point. Okay, now let's factorize the equation where I've got these two asterisks, and let's see what we get. So I'm going to go with perhaps, let's say 3x in the one bracket, 3x in the other. And if you don't have a calculator that can factorize this for you, you're going to need to use trial and error. So we get 6 and 15. That could work. 5, 2. So just that would probably give me the positive with that, the negative with that. Let's check our work. 3x times 3x is 9x squared. Minus 2 times plus 5 is minus 10. And minus 6x, 15x minus 6x is plus 9x. All right, these factors are perfectly fine. They're correct. So 3x minus 2 equals 0, or 3x plus 5 equals 0. This then tells us that 3x equals 2. Divide both sides by 3. So x would be equal to 2 over 3, or 3x would be equal to negative 5. Divide both sides by 3. So x would be negative 5 over 3. These are indeed simultaneous equations, and we also need to solve for y, which we'd get from our equation 3. So we'll say y is equal to 3 times x, right? Minus 2. So y would be 0. And here y would be 3 times x. 3 times minus 5 over 3, minus 2. And here y would be minus 7. Let me check my work. I'm happy with y equals 0. I'm happy with y equals negative 7. Our final answers could be expressed as x semicolon y equals 2 over 3 semicolon 0, or xy equals negative 5 over 3 semicolon negative 7. I'm going to underline the answers as my final answers, and that ends lecture 1 on applications of quadratic and related theory, solving equations and inequalities. Thank you, guys.